ਵਿਦਿਆਰਥੀਓ, ਫਿਜ਼ਿਕਸ ਪ੍ਰੈਕਟੀਕਲ ਦੀ ਇਸ ਕਲਾਸ ਵਿੱਚ ਤੁਹਾਡਾ ਸਵਾਗਤ ਹੈ। ਅਸੀਂ ਸਾਰੇ ਹੀ ਜਾਣਦੇ ਹਾਂ ਕਿ ਫਿਜ਼ਿਕਸ ਮੇਨਲੀ ਐਕਸਪੈਰੀਮੈਂਟਲ ਆਬਜ਼ਰਵੇਸ਼ਨਸ ਅਤੇ ਕੁਆਂਟੀਟੇਟਿਵ ਮੈਜ਼ਰਮੈਂਟਸ ਉੱਪਰ ਬੇਸਡ ਹੈ। ਤੁਸੀਂ ਲੈਂਥ ਦੀ ਮੈਜ਼ਰਮੈਂਟ ਦੇ ਡਾਇਰੈਕਟ ਅਤੇ ਇਨਡਾਇਰੈਕਟ ਮੈਥਡਸ ਤੋਂ ਪਹਿਲਾਂ ਹੀ ਜਾਣੂ ਹੋ। ਅੱਜ ਅਸੀਂ ਲੈਂਥ ਦੀ ਮੈਜ਼ਰਮੈਂਟ ਨੂੰ ਜਿਵੇਂ ਕਿ ਇੱਕ ਸਫੈਰਿਕਲ ਸਰਫੇਸ ਤੇ ਰੇਡੀਅਸ ਆਫ ਕਰਵੇਚਰ ਅਤੇ ਸ਼ੀਟ ਦੀ ਥਿਕਨੈਸ ਨੂੰ ਸਫੈਰੋਮੀਟਰ ਦੀ ਹੈਲਪ ਨਾਲ ਐਕਸਪੈਰੀਮੈਂਟਲੀ ਮੈਜ਼ਰ ਕਰਾਂਗੇ। When we wish to measure length accurately up to 1/10 or 1/100th of a millimeter, we use vernier calipers, screw gauge and spherometer. With vernier calipers generally available in the laboratory, we measure length correctly up to 0.01 centimeter. When lengths are to be measured with greater accuracy, say up to 0.001 centimeter, screw gauge and spherometer are used, which are based on the principle of micrometer screw. Spherometer is an instrument used for accurate measurement of very small thickness or the radius of curvature of a spherical surface, and that is why it is called a spherometer. For an example, it can be used to measure the thickness of a microscope slide or the depth of depression in a slide. Even the curvature of a ball can be measured using a spherometer.
It consists of a metallic tripod framework supported on 3 fixed legs of equal lengths. The tips of the 3 legs lie on the corners of an equilateral triangle, and they always lie in same plane. A vertical nut is fixed at the center of the tripod frame. An accurately cut screw passes through this nut. The axis of the screw is parallel to the 3 legs. A large circular disc terminating into a milled head is attached at the top of the screw. The circumference of circular disc is divided into 100 or 200 equal parts. This circular disc is also known as circular scale. A small vertical scale, usually divided into millimeter or half millimeter, is fixed at one end of the tripod frame. This vertical scale is parallel to the axis of the screw, and it just touches the rim of the circular disc. This vertical scale is also known as pitch scale.
Pitch of the screw is the distance moved by the spindle per revolution. The screw has a known pitch such as 1 millimeter. To measure the pitch of the screw, first of all, we find the value of one division on pitch scale. Then bring 0 of circular scale opposite to pitch scale and rotate the screw by n complete rotations, and note the distance d moved by the screw on the pitch scale. The pitch P of the screw would be equal to d by n millimeter. Let us see what is the pitch of the screw.
If an accurately cut single-threaded screw is rotated in a closely fitted nut having evenly spaced threads matching the threading on the screw, then in addition to the circular motion of the screw, there is a linear motion of the screw head in the upward or downward direction along the axis of the screw. The linear distance moved by the screw when it is given one complete rotation is equal to the distance between the two consecutive threads as measured along the axis of the screw. This distance is called the pitch of the screw and is represented by small p. In most of the cases, it is either 1 mm or 0.5 mm.
On the other hand, least count of a spherometer is the ratio of the pitch and the number of divisions on the circular scale. If there are n divisions in the circular scale on the circumference of the disc, then least count of the spherometer would be p by n millimeter or d by n millimeter.
A circular disc is fixed on one end of the screw and the circumference of the disc is normally divided into 100 or 50 equal parts. If it is divided into 100 equal parts, then the screw moves upward or downward by 1 by 100 of the pitch if the circular scale is rotated through one circular scale division. It is the minimum distance which can be accurately measured and so is called the least count of the screw. If pitch is 0.5 mm and there are 100 divisions on circular scale, then least count would be 0.5 mm by 100, that is 0.005 mm or 0.0005 centimeter.
Spherometer, which works on the principle of micrometer screw, basically consists of two scales. One is the pitch scale. It is a scale running parallel to the axis of the screw. It is graduated into millimeter or half millimeter. The second one is circular or head scale. It is marked on the circumference of the circular disc attached to the screw. Let us now find the thickness of a sheet using a spherometer. Objective for this activity is to measure the thickness of a given sheet using a spherometer.
Apparatus required for this experiment are a spherometer, sheet, and a plain glass slab. Theory for this experiment is ਇੱਕ ਗਲਾਸ ਸਟ੍ਰਿਪ ਦੀ ਥਿਕਨੈਸ ਨੂੰ ਮੈਜ਼ਰ ਕਰਨ ਲਈ ਅਸੀਂ ਇੱਕ ਵੱਡੇ ਸਾਈਜ਼ ਦੇ ਗਲਾਸ ਉੱਪਰ ਸਫੇਰੋਮੀਟਰ ਰੱਖਦੇ ਹਾਂ ਤਾਂ ਕਿ ਇਸ ਦੀਆਂ 3 ਲੈਗਸ ਇਸ ਦੇ ਟਿਕਿਆ ਰਹਿਣ। ਸਕਰੂ ਨੂੰ ਸਫੀਸ਼ੀਐਂਟਲੀ ਰੇਜ਼ ਕਰੋ ਤਾਂ ਕਿ ਸਮਾਲ ਗਲਾਸ ਸਟ੍ਰਿਪ ਜਿਸ ਦੀ ਥਿਕਨੈਸ ਡਿਟਰਮਿਨ ਕੀਤੀ ਜਾਣੀ ਹੈ ਨੂੰ ਸਕਰੂ ਦੇ ਅੰਦਰ ਰੱਖਿਆ ਜਾ ਸਕੇ। ਫਿਰ ਸਕਰੂ ਨੂੰ ਜੈਂਟਲੀ ਡਾਊਨਵਰਡ ਟਰਨ ਕਰੋ ਜਦੋਂ ਤੱਕ ਕਿ ਸਕਰੂ ਟਿਪ ਗਲਾਸ ਸਟ੍ਰਿਪ ਦੇ ਸਰਫੇਸ ਨੂੰ ਟੱਚ ਨਾ ਕਰੇ। ਤੁਸੀਂ ਇਹ ਕਿਸ ਤਰ੍ਹਾਂ ਚੈੱਕ ਕਰੋਗੇ ਕਿ ਸਕਰੂ ਟਿਪ ਗਲਾਸ ਸਟ੍ਰਿਪ ਦੇ ਸਰਫੇਸ ਨਾਲ ਟੱਚ ਕਰ ਰਹੀ ਹੈ? ਇਸ ਨੂੰ ਟੈਸਟ ਕਰਨ ਲਈ ਸਫੇਰੋਮੀਟਰ ਦੀਆਂ ਆਊਟਰ ਲੈਗਸ 'ਚੋਂ ਇੱਕ ਨੂੰ ਜੈਂਟਲੀ ਪ੍ਰੈਸ ਕਰੋ ਅਤੇ ਬਾਕੀ ਬਚੀਆਂ 2 ਲੈਗਸ ਜਾਂ ਸੈਂਟਰਲ ਸਕਰੂ ਦੇ ਹੇਠਾਂ ਇੱਕ ਥਿਨ ਪੇਪਰ ਰੱਖਣ ਦੀ ਕੋਸ਼ਿਸ਼ ਕਰੋ। ਜੇ ਇਹ ਕਿਸੇ ਵੀ ਥਾਂ ਤੇ ਐਡਜਸਟ ਨਾ ਹੋਵੇ ਤਾਂ ਅਸੀਂ ਕਹਿ ਸਕਦੇ ਹਾਂ ਕਿ ਸਕਰੂ ਗਲਾਸ ਸਟ੍ਰਿਪ ਦੇ ਅਪਰ ਸਰਫੇਸ ਨੂੰ ਟੱਚ ਕਰ ਰਿਹਾ ਹੈ।
ਸਰਕੂਲਰ ਸਕੇਲ ਦੀ ਰੀਡਿੰਗ ਨੋਟ ਕਰੋ ਜਿਹੜੀ ਕਿ ਪਿਚ ਸਕੇਲ ਦੇ ਨਾਲ ਸਟ੍ਰੇਟ ਲਾਈਨ ਵਿੱਚ ਹੈ। ਸਕਰੂ ਦੇ ਅੰਡਰ ਗਲਾਸ ਸਟ੍ਰਿਪ ਰਿਮੂਵ ਕਰੋ ਅਤੇ ਸਕਰੂ ਨੂੰ ਡਾਊਨਵਰਡਸ ਟਰਨ ਕਰੋ ਜਦੋਂ ਤੱਕ ਕਿ ਸਕਰੂ ਦੀ ਟਿਪ ਗਲਾਸ ਸਲੈਬ ਦੇ ਪਲੇਨ ਸਰਫੇਸ ਨਾਲ ਟੱਚ ਨਾ ਕਰੇ। In doing so, count the number of complete rotations made by the disc. Say N1 is the number of complete rotations, taking initial reading of circular scale as a reference point, and note the number of additional circular scale divisions x, which are in excess of the complete rotations. Again, strip the thickness T is equal to N1 into pitch plus x into least count. J A initial ਅਤੇ B circular scale ਦੀ final reading ਹੈ ਅਤੇ 0 of circular scale does not move across the vertical scale. Then, for circular scales having clockwise graduation, x बराबर होवेगा a minus b ਦੇ, ਜਦੋਂ ਕਿ for a circular scale having anti-clockwise graduation, x बराबर होवेगा b minus a ਦੇ. But if 0 of circular scale moves across the vertical scale, then for clockwise graduation, x बराबर होवेगा 100 minus a minus b ਦੇ, ਜਦੋਂ कि for a circular scale having anti-clockwise graduation, x बराबर होवेगा 100 minus b minus a ਦੇ.
Procedure. For determination of least count, first of all we measure the pitch of the screw. For this, find the value of one division on pitch scale. Then bring 0 of circular scale opposite to pitch scale and rotate the screw by 2 complete rotations. Note the distance moved by the screw on the pitch scale. The pitch of the screw is given as distance moved by the screw divided by the number of complete rotations. And the least count of the screw is the ratio of pitch of the screw with number of divisions on circular scale. For this spherometer, pitch is 0.5 millimeter and number of divisions on circular scale is 100. Hence, the least count is 0.005 millimeter. Let us now determine the thickness of sheet. For the determination of the thickness of a sheet, place the spherometer on a big size glass slab so that its 3 legs rest on it. Raise the screw sufficiently so that a small sheet, whose thickness is to be determined, could be placed below the screw. Then gently turn the screw downwards till the screw tip just touches the surface of the sheet. Check whether the screw is touching the given sheet or not. Note the reading of the circular scale, which is in line with the pitch scale. Here it is 0 millimeter. Remove the sheet just below the screw and turn the screw downwards till the tip of the screw just touches the plane surface of the glass slab. Again check whether the screw is touching the glass slab or not. In doing so, count the number of complete rotations N1 made by the disc, taking initial reading of the circular scale as the reference point. Here it is 5 rotations. And note the number of additional circular scale divisions x, which are in excess of the complete rotations. This is 30 divisions. Record the readings in the observation table and calculate the thickness of the sheet. In this case, thickness of sheet is 2.650 millimeter. Repeat the experiment for different position of the sheet and record the readings in the observation table and calculate the thickness of the sheet.
On calculation, we get mean corrected value of the thickness of the sheet, which is equal to T1 plus T2 plus T3 plus T4 upon 4. That is 2.650 plus 2.655 plus 2.650 plus 2.650 upon 4. Hence, the mean value is 2.651 millimeter. Result. Hence, the thickness of the given sheet is 2.651 millimeter. Let us now find radius of curvature of a convex surface using a spherometer. Objective for this activity is to measure the radius of curvature of a given spherical surface using a spherometer.
Apparatus required for this experiment are a spherometer, convex lens, and a plain glass slab. Theory for this experiment is convex surface ਦੇ curvature r ਦਾ radius measure ਕਰਨ ਲਈ spherometer ਨੂੰ convex surface ਤੇ ਰੱਖਿਆ ਜਾਂਦਾ ਹੈ ਤਾਂ ਕਿ ਸਾਰੀਆਂ 3 legs ਅਤੇ screw ਇਸ ਨੂੰ ਟੱਚ ਕਰਨ। ਇਸ ਪੋਜੀਸ਼ਨ ਵਿੱਚ ਪਿਚ ਸਕੇਲ ਦੇ opposite circular scale division find ਕਰੋ। Again, spherometer ਨੂੰ glass slab ਦੇ plane surface ਤੇ ਰੱਖੋ ਅਤੇ screw ਨੂੰ downward ਉਦੋਂ ਤੱਕ move ਕਰੋ ਜਦੋਂ ਤੱਕ ਕਿ central screw glass surface ਨੂੰ touch ਨਾ ਕਰੇ।
In doing so, count the number of complete rotations, say N1, made by the disc by taking the initial reading of the circular scale as a reference point and note the number of additional circular scale divisions x which are in excess of the complete rotations. फिर central screw वालों move distance h बराबर होवेगा N1 गुणा pitch जमा x गुणा least count दे।
On the other hand, to find the radius of curvature of concave surface, first put the spherometer on plane surface, then put it on concave surface to find h. Let A x2, E x1b represent the vertical section of the sphere of which the given surface forms a part. The vertical section passes through one of the outer legs A and central screw D and the center of sphere O. OD is the radius of curvature. Here, third leg C is not visible. Let the height of the curved surface DG, that is, sagitta, is equal to h. This is the height of central screw above the plane ABC, which can be measured by the spherometer.
In this circle, the distance DE is a diameter which bisects the chord AB. If we know the distance DG and AG, we can find the radius of the circle R. From geometry of similar triangles, we have DG into GE equal to AG into GB. Since AG is also equal to GB, therefore AG square is equal to DG into GE, or AG square is equal to DG into 2R minus DG. AG is simply the radius of the circle formed by the legs. To find this radius, we measure the distance from the central leg when it is coplanar with the other legs to any of the outer legs. let AG is equal to A. Then, in other words, A square is equal to H into 2R minus H. On rearranging, we get 2R minus H equal to A square upon H. That is, R is equal to A square upon 2H plus H by 2. However, the outer fixed legs of the spherometer determine the distance A. Let L be the distance between any of the two legs. Then, from the geometry of equilateral triangle ABC, AG or BG or CG is equal to A and CG is equal to 2/3 of CS. Hence, A is equal to 2/3 of square root of L square minus L square by 4, or A is equal to L by root 3. Therefore, R is equal to L square upon 6H plus H by 2.
Procedure. First of all, we measure the distance between any two legs. For this, raise the central screw of the spherometer and press the spherometer gently on a white sheet so as to get pricks of the three legs. Mark these pricks as A, B and C. Then measure the distance between the pricks by joining the points as to form a triangle ABC. Note the distances AB, BC and AC. Here, AB, AC and BC are of 3.3 centimeter. Hence, the mean value of the distance between any two legs is 3.3 centimeter. For determination of radius of curvature, place the spherometer on a convex surface so that its three legs are touching it. Then gently turn the screw downwards till the screw tip just touches the surface. Check whether the screw is touching the given surface or not. Note the reading of the circular scale, which is in line with the pitch scale. Now, place the spherometer on a big size glass slab so that its three legs rest on it. Then gently turn the screw downwards till the screw tip just touches the surface of the glass slab. Again check whether the screw is touching the glass slab or not. In doing so, count the number of complete rotations N1 made by the disc, taking initial reading of the circular scale as the reference point. Here, N1 is equal to 8. And note the number of additional circular scale divisions X, which are in excess of the complete rotations. Here, it is 0 division. Record the readings in the observation table and calculate the sagitta of the given curved surface. In this case, sagitta of the given curved surface is 4.000 millimeter. Repeat the experiment and record the readings in the observation table and calculate the sagitta of the given curved surface. On calculation, we get mean corrected value of the sagitta, which is equal to H1 plus H2 plus H3 plus H4 upon 4, that is 4.000 plus 3.990 plus 4.000 plus 4.000 upon 4. Hence, the mean value is 3.998 millimeter or 0.3998 centimeter. Since radius of curvature r is equal to L square upon 6h plus h by 2. Therefore, r would be equal to 3.3 square upon 6 into 0.3998 plus 0.3998 by 2, that is 4.5398 plus 0.1999 centimeter or 4.7397 centimeter.
Result. Hence, the mean value of Sagitta is 3.998 millimeter and the radius of curvature is 4.74397 centimeter. Let us have a look on the precautions to be incorporated for these experiments. The screw should move freely without friction. For same set of observations, the screw should be moved in the same direction to avoid backlash error of the screw. Excessive rotation should be avoided. On the other hand, there may be some sources of error. Care should be taken for such errors also. The screw may have friction. The spherometer may have backlash error. Circular scale divisions may not be of equal size. Given object may not be uniform. ਹੁਣ ਅਸੀਂ ਅੱਜ ਦੇ ਵਿਸ਼ੇ ਦੇ ਐਂਡ ਤੇ ਆ ਗਏ ਹਾਂ। ਹੁਣ ਅਸੀਂ ਤੁਹਾਨੂੰ ਕੁਝ ਕੁਐਸਚਨਸ ਪੁੱਛਾਂਗੇ ਇਹ ਵੇਖਣ ਲਈ ਕਿ ਤੁਸੀਂ ਅੱਜ ਦੇ ਇਸ ਟੌਪਿਕ ਵਿੱਚੋਂ ਕੀ ਸਿੱਖਿਆ ਹੈ। My first question is, describe the principle of a spherometer. The answer says, the principle of a spherometer is that when an ideal screw moves in a fixed nut, the translatory motion of the screw is proportional to the rotation given to the screw. The next question is, why is a spherometer so called? The answer, it is called a spherometer because it measures radius of curvature of spherical surfaces. The next question is, what are the various types of motions possessed by a screw? Well, the screw has two types of motions. Axis has linear motion and surface has circular motion. The next question, what is least count of a screw gauge? The answer is, if there are n divisions in the circular scale on the circumference of the disc and pitch is P, then least count of the spherometer would be P by n millimeter. Next question is, what is the least count of commonly used spherometer? The answer, it is 0.0005 centimeter. Have a look at another question. Give a formula for the determination of radius of curvature by spherometer. The answer, radius of curvature r is equal to L square upon 6h plus h by 2. ਮੈਨੂੰ ਉਮੀਦ ਹੈ कि तुहानू आज दे ये एक्सपैरीमेंट्स चंगी तरह समझ आ गए होंगे। एक्सपैरीमेंट्स ते ध्यान देण लई धन्नवाद। अगली बार एक होर नवे विषय नाल फिर मिलांगे। तद तक गुड बाय।